Hello, welcome to Unit 9, Lesson 2. This is Professor Blackman. Today we're going to be talking about inverse functions. We're also going to be talking about how to find inverse equations. We're going to be able to test for one-to-one and use the horizontal line test when we're given graphs. All right, let's get started. So the first thing we're going to talk about with a inverse relation is a set of ordered pairs or a list of ordered pairs. And so basically what we're going to do is just interchange the first and second coordinates, or just really just switch the x's and the y's. So then this first example, 7, 8 becomes 8, 7. Negative 2, 8 becomes 8, negative 2. 3, negative 4 becomes negative 4, 3. 8, negative 8 becomes negative 8, 8. And that is your list of points. The next one, negative 1, since those are the same, when you switch them, they would still be negative 1, negative 1. And negative 3, 4 becomes 4, negative 3. All right, so that's how we do it with a list of ordered pairs. All right, here we're going to do it with the equations. I've got a little box right here that says replace f of x with y, interchange x and y, solve for y, and then change y to the f raised to the power of negative 1 x, which we read as the inverse of the function of x. So right here, we're going to switch x and y, and so this will become y to the third x equals negative 5, which would then become y to the third. We get rid of this x by dividing it, so negative 5 over x. And then this is a third power, but we need cube root. So we are going to cube root. And so then we get y equals the cube root of negative 5 over x. And then what you need to, our last step is to change that y to the inverse function of x, which is now, everything on the right would stay exactly the same. All right, let's do this one. Let's switch x and y. Well, we have multiple y's, so we'll just do y equals x squared minus 2x. And as you see here, y is already isolated. So inverse function of x is equal to x squared minus 2x. All right, let's look at another example. All right, here we're going to test to see if something is one-to-one. And so basically what you're going to do is you're going to see if f of a equals f of b, then a equals b. So what you're going to do is you're going to take the f of x and make it the function of a and the function of b, set them equal to each other, and then see if a equals b. So this will be 1/3 f of a, which is now a minus 6, equals 1/3 b minus 6. So we have both functions here, and then we're going to test to see if we can make them equal each other or make a equal b. I'm going to add 6 to both sides. 1/3 a equals 1/3 b. Multiply everything by 3, and you get a equals b. So the answer to this question is yes. This is a 1/3 x minus 6 is a function that is one-to-one. All right, let's look at g of x. So we're going to take and write that as 1 minus a squared equals 1 minus b squared. So 1 minus a squared, if I subtract 1 from both sides, then I get negative a squared equals negative b squared. Divide both sides by negative 1, and I get a squared equals b squared. So as you see, a does not equal b here, so this is a no. because 1 can equal 1 and 1 can equal negative 1. So 1 minus x squared is not a one-to-one function. Let's look at our next example. All right, just like on the previous examples, we're going to take and plug in and make this f of a. So f 5a minus 8 needs to equal 5b minus 8. And this gives us, add 8 to both sides, 5a equals 5b, divide by 5 both sides, and a does in fact equal b. Now, we're also told in this one that we need to find the formula for its inverse. So just like previously, we would take and make this y equals 5x minus 8, and then switch them, x equals 5y minus 8, and then solve for y. So add 8 here, and you get x plus 8 equals 5y, divide by 5, and you get f inverse of x equaling x plus 8 over 5, or 1/5 x plus 8/5, depending on if you divide the 5 by the entire side or individually. Either way is an acceptable answer. All right, let's look at the next example. All right, so first we're going to test to see if it is one-to-one. So 2a plus 1 needs to equal 2b plus 1. So that's 2a subtracting 1 equaling 2b. Divide by 2, and you get a equals b. So it is one-to-one. So now that we know it's one-to-one, we're going to find its inverse. And so y equals 2x plus 1, and then switch your x and y's, and then solve for y. Subtract 1, x minus 1 equals 2y, divide by 2, and you get f inverse of x is equal to x minus 1 over 2, or 1/2 x minus 1/2. All right, let's look at the next example. So let's go ahead and start with determining if this is one-to-one. So we're going to take a plus 4 over a minus 3 and set that equal to b plus 4 over b minus 3. Now we're going to multiply by the denominator of both, or cross multiply, however you want to look at it. So you get a plus 4 times b minus 3 equals b plus 4 times a minus 3. And then we need to multiply all that out. We get ab minus 3a plus 4b minus 12 equals ab minus 3b plus 4a minus 12. And this AB and this AB will cancel each other out. This negative 12 and this negative 12 will cancel each other out. And I'm going to subtract 4A from both sides and subtract 4B from both sides. And we get negative 7A equals negative 7B, which if you easily divide by 7, you get negative 7, you get A equals B. So it is one-to-one. So this part is done. Well, now we need to find the inverse formula. So we're going to do y equals x plus 4 over x minus 3. Switch your x and y's, x equals y plus 4 over y minus 3. Multiply both sides by y minus 3. Cancels that. xy minus 3x equals y plus 4. Now I need to get all my y's to one side, so I'm going to move this y over. Move this negative 3x over by adding 3x. And so that cancels and that cancels. And you get xy minus y equals 3x plus 4. Now, a lot of students will get stuck right here because they have two y's, but we can think of this as like a GCF, factor out that y, and now you have x minus 1 equals 3x plus 4. Divide both sides by that x minus 1. And you get y equals 3x plus 4 over x minus 1, which of course you need to change to the inverse of x is equal to 3x plus 4 over x minus 1. All right, let's look at another example. All right, this is the horizontal line test. So in past lessons, we did the vertical line test to determine if something was a function. Well, if we're using the horizontal line test, all these are already functions. So if I draw a vertical line here, touches once, touches once, touches once, touches once, touches once, touches once. Same for all the other examples. So we know that these are functions. Now what we're going to do is test to see if these are one-to-one functions. So every y has one x and every x has one y. If we draw a line here, touches once, touches twice, no, not one-to-one. Touches once, touches once, touches once, touches once. All of these only touch once. This is a one-to-one function. Touches once, but here touches multiple times. Not a one-to-one function. All right, that's all I have for you today. Happy studying.